So welcome back. In this video, we are going to derive the general equation of a wave on a string. Suppose you tie a string to the wall, that's it. The other end, you hold it in your hand. You give a bump like this, tick. Some displacement like this is produced, so it will go forward like this and then clash with the wall. Like this, if you continuously do, a wave-like thing is produced. For simplicity, produce one bump like this. Suppose some time is there, t equals to t naught. You produce the bump like this. It is at the origin, x equals to 0 in your hand. And the bump is moving forward like this with the speed v. So at some time t equals to t, the bump has covered a distance x. So the bump is moving with a velocity v. How much time the bump has taken to come from here to here? Distance by time, distance by speed. Distance is x, speed is v. So it has taken x by v time to come from the origin to this position, from here to here. The time taken by bump to come from origin to position x is x by v. That means x by v seconds earlier, where was it? It was at the origin. What is x by v second earlier? It was at the origin. So what is the time when the bump was at the origin? T minus x by v. Because the current time is t and x by v time earlier it was at the origin. So t minus x by v is the time when the bump was at the origin. And we know the equation of motion at the origin. The displacement of the particle at the origin, y displacement, is a function of time. Displacement of the particle at the origin in the y-axis is a function of time. And we have obtained the time. What is the time? T minus x by v. When the time is t minus x by v, this bump is at the origin. The bump is at the origin. And we want to find the equation of the bump at this position. And it is exactly the same as it was at the origin, x minus v time earlier. Imagine it. So, y is function of time. Time is t minus x by v, where x is the distance from the origin. Therefore, we obtain the general equation of the wave. You give the time, you give the x, where x is the position on the string. You can obtain the displacement of a particle at any particle, because all the particle is doing different motion, but using the motion of the particle at the origin, we are obtaining the motion of all the particles, displacement in the y-axis. Now if the particle is only doing SHM, then all the particles will be doing SHM in the y-axis. SHM means simple harmonic motion, and then this wave can be called as a progressive harmonic wave. So the general equation of any wave is function of t minus x by v. The displacement on the y-axis, its relation with time and x, where x is the distance from origin, is known. So that's it. Thank you for today.